Hi class, Mr. Morris, continuing this crash course in solutions from pre-AP chemistry. I want to talk to you about reading a solubility curve, and I have switched to the document camera because I think that it's going to be easier for you to follow along if I do it this way for this section of the notes. Notice the axes on the graph below. So this is a solubility curve. You've seen a couple of these in the notes previously, but we didn't really talk about them. Okay. So first we want to notice the axes. Down here, this is temperature in degrees Celsius, if that's not clear on your camera or on the video. That's what that says. And this is the number of grams of solute that will dissolve in 100 grams of water. So it's specific to 100 grams of water. I want you to notice that the axes on the graph below are temperature on the x-axis and grams of solute that will dissolve on the y-axis. Another word for this that will sometimes show up is solubility, because it means the same thing as the number of grams that will dissolve in 100 grams of water. The x-axis is the temperature, we just said that. The solubility of each of these substances is affected by temperature. So you can see that as the temperature changes, the solubility changes. It either goes up or it goes down. So we want to walk through a few examples on here. At any given temperature, the line represents a saturated solution at given temperatures. So at 10 degrees Celsius, if I'm looking at sodium nitrate, I get about 80 grams that would dissolve in 100 grams of water. It's temperature specific, and that is the saturated solution, sodium nitrate. That's the most that will dissolve, is 80 grams. So any amount of solute on the line indicates the solution is saturated at that temperature. Any amount of solute below the line indicates the solution is unsaturated at that temperature. So again, I'm just going to focus on this NaNO3 line. I think it's helpful. Okay. If I'm talking about that 10 degrees Celsius, let's say it was around 60 grams that dissolved. That's less than the maximum. It's less than the maximum amount that is possible to dissolve at 10 degrees Celsius. So that would be an unsaturated solution of sodium nitrate. Any amount above the line in which all of the solute is dissolved shows the solution is supersaturated. So if I were to say I dissolved 100 grams, I have 100 grams of sodium nitrate dissolved at 10 degrees Celsius. That's above the line. That would be a supersaturated solution. Then we get to this bullet point. This is where it gets a little confusing for students sometimes. If the amount of solute is above the line, but is not all dissolved, so some of it's not dissolved, the solution's not supersaturated. If we have any undissolved solute, it's not a supersaturated solution. It's a saturated solution, and some solid is left undissolved. And we could figure out how much. Let's just do a quick example of that. Let's say that I have 100 grams that I'm trying to dissolve at 10 degrees Celsius of sodium nitrate. How many grams would not dissolve? Well, it's got 20 more grams than what the maximum amount possible is. So if it's not a supersaturated solution, if I'm just stirring it up and I know there's some that's left at the bottom, I could figure out there's 20 grams left at the bottom, because that's the difference between the amount I dissolved and the maximum amount that can dissolve. Remember, to make a supersaturated solution, you would heat it up and then you'd cool it back down very slowly. And as we cool it down, if we're left with more dissolved than what is normally possible, that's a supersaturated solution. If you need clarification on that, I'd be happy to answer questions about that later. That's a little bit of a tricky subject. Solutes whose curves slant upward with an increase in temperature are usually solids, because we said that solids, if you increase the temperature, they tend to be more soluble. Okay? If we have a gas solute, it's going to do the opposite. We're going to have a downward slope like with NH3. Because solutes whose curves move downward tend to be gases, because that means that as the temperature increases, the solubility is decreasing. Let's just do a little bit more with solubility curves. On the next page, I've got basically the same solubility curve, but we want to ask some questions about it. At 10 degrees Celsius, so that's right here, and I'm talking about sodium nitrate, so let's highlight sodium nitrate in yellow just for our reference. All right, at 10 degrees Celsius, sodium nitrate, what's the solubility of it? What's the solubility of sodium nitrate in 100 grams of water? Well, this says 100 grams of water. At 10 degrees Celsius, it's going to be wherever that dot is, where it intersects with the line for sodium nitrate. So that's really close to 80. I know it's a little below, but I'm just going to call it 80 grams of sodium nitrate in 100 grams of water. So we could say 80 grams per 100 grams of water. If a solution of 50 grams of sodium nitrate, same thing. If we had 50 grams dissolved in 100 grams at 10 degrees Celsius. All right, so that would be right here. What's the solution? Saturated, unsaturated, or supersaturated? Well, it's less than the maximum amount dissolved, so we would say it's unsaturated. If a solution has 80 grams of sodium nitrate dissolved in 100 grams of water at 10 degrees Celsius, well, 100 grams just means this. 80 grams of sodium nitrate, okay, so that's right here. At 10 degrees Celsius, yeah, 10 degrees Celsius, so it's right on the line. That is saturated. Saturated means it's right on the line. It's right at the maximum amount that can be dissolved at that temperature. If a solution has 90 grams of sodium nitrate dissolved in 100 grams of water at 10 degrees Celsius, 100 grams again, 10 degrees Celsius, but this time we have 90 grams of sodium nitrate. Always check to make sure you're looking at the right curve. Well, that's more than enough, and it is dissolved. This is supersaturated. All right, solubility curves problems down here. Some of these are a little different. What relationship does the solubility and temperature have for most of the substances? Well, they're all going up. Not all of them, but most of them are going up, so I would say direct. That means that they're probably what state of matter? Solid. Okay. Which substance is the exception? NH3 is the exception. Why do you think that is? If you said it already, it's because NH3 is a gas. Okay, which compound's solubility appears to be the most affected by temperature? That means as the temperature changes, it changes more than the others. That's going to mean that the slope is steeper than the others. Okay, the steepest slope is the one that's most affected by the temperature. It looks to me like for the most part it's KNO3. In most areas it's KNO3. Which one appears to be least affected by temperature? Well, that's going to be your flattest line. I think that's NaCl. And which compound is the least soluble at 10 degrees Celsius? That means less will dissolve at 10 degrees Celsius than other compounds. Well, look for the line that's the lowest at 10 degrees Celsius. It's this spot right here, which is KClO3. Okay, then it asks us which is the most soluble at 10 degrees Celsius. The most soluble is going to be way up here. That's going to be Ki. potassium iodide. So approximately how many grams of sodium nitrate can be dissolved in 100 grams of water at 60 degrees Celsius? That's a different type of question. 100 grams of water, 60 degrees Celsius here, and we're talking about sodium nitrate. That's this same one that we've been looking at. All right, go up. It looks like, I don't know, it's slightly less than 125, so I'm going to call it 124. Then it asks me this: what if it was in 200 grams of water? In 200 grams of water, well, how would I know how to do that? This tells me how much would dissolve in 100 grams of water. Well, if I double the amount of solvent, I can double the amount of solute that would dissolve. So I know 124 grams would dissolve in 100 grams. Then in 200 grams, I would get 248 grams dissolving. What about if it was in 50 grams of water? Well, that's half of what I started with. That's half of 100. So it'll be half of this, which is going to be 62. If I did my math right in my head, 62 grams. All right, at what temperature would 90 grams of sodium nitrate dissolve in 100 grams of water? At what temperature? All right, I'll tell you the most common mistake on this problem is students just get in a habit and they go, okay, I'm looking for 90 grams. And they look down here and they go, 90 grams. Okay, sodium nitrate. Wait a second, that doesn't... But that's not right. Because this is the temperature. I'm looking for 90 grams of sodium nitrate. So we need to go and find 90 grams on this axis and then go over to sodium nitrate. I want to know the temperature. I'm looking for the temperature this time. So go down to, I'd say 22, about 22 degrees Celsius. All right, all of these questions at the bottom are practice problems that are very similar to the ones at the top of the page. I'm not going to go through those because we already went through a handful of them up here. I want you guys to look over these yourself. And if you have questions, let me know. I'll try to post an answer key for these problems at some point. Just one thing you might want to do is when you switch to a different type of compound like KCl, if you have a bunch of highlighters, you could highlight it in a different color, and that just might make it easier for you to separate which line is which. All right, that's it for solubility curves. And then I'm going to pause the video here and we'll move on to our next topic.